So today we're going to go through the video for how to do problems using the rules for adding, the rules for subtracting, the rules for multiplying, the rules for dividing, and then we're going to do a combined problem that uses all these principles. And this is obviously by me, Jawad. So the first rule we're going to do today is the rule of adding. So for the rule of adding, let's say I have the numbers 51.05 and my second number is 1200, and we are obviously adding them. So how would we do this? The first thing we have to pay attention to is how many significant digits we have. So the presence or absence of decimals. So here we can see that decimal is present, so we move from this way and see how many significant digits we have. So 1, 2, 3, 4. So the last one is our guess digit, so this is our guess digit. This one doesn't have any decimal places, so we move from this way, and our guess digit will be here, and there's two significant digits since we ignored the zeros. So now we know where our guess digits are. This next thing we are going to do is that we are going to write the answer that the calculator gives us, or the one we get mathematically. So we obviously know this is our answer. Now what we have to do is that there's two rules that we have to follow. The first rule, when we doing rules of addition, is that our position of guess digit. So we look at our position of guess digit for both numbers. The second rule that we have to follow is the least precise number. So the least precise guess digit. Which guess digit is the least precise? So let's say here we can obviously see this is one of our guess digits. So if we change the color here, this is our guess digit 1, and since we carried this down, this is our second guess digit. So now we know the positions of the guess digits. This one is in the hundreds column, this one is in the thousands column. So which one is the least precise? So for the least precise, we'll always look from the left side of the board and see which one's closest. So obviously hundreds is more precise than thousands, so this is our least precise number. So this is the number that we're going to base our significant digit and the rule for adding calculations on. So now here we'll look at the number that's after the guess digit. So obviously it's 5, and any number that's 5 or above makes the guess digit go up by 1. Therefore, the answer is 1300. Let's say this was not 5 but less than 5, then the number would still be the same and it would be 1200 as our final answer. Here the answer is 1300. So that's how you do the rules of adding. So the second rule we're going to do is the rule of subtracting. So how do you do the rule of subtracting? We're going to use the same numbers as last time. So 1200 minus 51.05. So the first thing, as obviously I mentioned before, we have to look for significant digits. Since this number doesn't, the first number doesn't have any decimal places, we move from the right side and zeros are ignored, and this is our guess digit, and this number has decimal place, so we move from the left and there's 4 significant digits, and this is our guess digit. So we are gonna just do the calculator math here. So if we do the calculator math, the answer we are gonna get is 1148.95. So 1148.95 is the calculator answer that you'll get. So we're gonna bring our guess digit. So here, this one's here, and this is the guess digit that's carried down, so it's right here. Now we have to figure out how to do the rule and how to apply the significant digit. So here the rules are the same as last time for the rule of adding. The first thing we look at is our position of guess digit, and the second thing we're going to look at here is least precise guess digit. So position and precision are the two things that we're going to look at. So if we go back to the number here, the position of the guess digit, this one's again in the this one's again in the hundreds column, and this one is in the thousands column. So as we said, the least precise is the one from the left, so obviously this one's the least precise. Therefore, our answer is going to be 1100. How do I know that? Because since this is a less precise, we are going to use this as a number of significant digits, and this number, the one after the guess digit, it's below 5. As long as below 5, the same numbers are brought down. If this was 5 or above, we would apply the rule and add 1 to it, and this would become 1200. But since this is less than 5, the final answer is 1100. So that is our rule of subtracting. So now we are going to look at the rule for multiplying. So the rule for multiplying is a little different from the rule of adding and subtracting. Different rules apply. So first we're going to get our numbers. 35.0, let that be our first number, and our second number would be, let's say, 100. And we are obviously multiplying them. So the rules here are slightly different, so I'm going to go over them first. The first rule is that instead of looking for guess digits as last time, we look for the number of significant digits. So number of significant digits in both numbers, so this one and this one. And our second rule is that after we get the number of significant digits, we choose the lowest number of significant digits. So the one that has the lowest number of significant digits is the one that we choose. So let's come back to the problem here. So 35.0, there's a decimal point here, so we obviously move from the left, and 1, 2, 3. 3 significant digits. And this one doesn't have a decimal point, so we're going to move from the right, and we ignore the zeros, and therefore there's only 1 significant digit. So now if we do a regular math, the answer we're going to get is 3500.0. So now we choose our second rule, which is lowest number of significant digits. So this one has 1, 2, 3, 3 significant digits. This one has 1. So we're going to choose 1 significant digit since that's our lowest number. And since there's a decimal point here, so obviously we move from this way. So this is our lowest significant digit choice. So now do we write down 3 or do we write down 4? That depends on the number after the last number of the significant digit. So this number here is 5. So if this number was below 5, 3 would stay 3. But since this number is 5 or above, so we're gonna convert this 3 into a 4, and then we're still gonna maintain 1 significant digit because that's what we got from here. So as you can see, there's no decimal place, so we move from this way. Zeros are ignored. 1 significant digit. So our final answer is 4000, and that's the rule for multiplying. So the next thing we're going to look at is the rule for dividing. This is our last rule. So let's say our numbers are 9.00 divided by 2.0, and we're dividing it. So the rules for dividing is actually very similar to the rules for multiplying. Our first rule is that we look for the number of significant digits in each of the numbers that we have. The second rule is that we look for which one is the lowest number. So the lowest number of significant digits is the one that we are going to choose for math. So if we come back to the math, obviously here we can see there is a decimal place here. So 1, we are gonna move from the left. So 1, 2, 3, 3 significant digits. And this one also has a decimal place, so we move from this way as well. And this one has 2 significant digits. So 3 significant digits, 2 significant digits. We are obviously gonna use the second one based on our formula, which is lowest number of significant digits. So if we do our regular math, the answer will be 4.50. Since we are using this one, so 2 significant digits, so we come this way since there's a decimal place, so this way, and 1, 2, 2 significant digits. Therefore our final answer will be 4.5. Why is it 4.5 and not 4.6? Because this number is less than 5. If this number was 5 or above, this will become 4.6. So our final answer is 4.5. This is the rule for dividing. So now that we know the rules, we're going to do a combined problem which is going to combine all the rules. So let's say our question is right here, A and B, C. So we are given B and C for the triangle, and we are asked to solve for A. So since this is a right angle triangle, we can use the Pythagorean theorem, which I wrote out here. A squared equals B squared plus C squared. If we rearrange it, we square root on both sides, so A squared becomes A, and B squared plus C squared becomes square root of B squared plus C squared. And then now the easiest way to solve it is just to go ahead and do the math first and then worry about significant digits. So B, from here it's 5.6 and C is 8.93, so I plug those values in. 5.6, 8.93, that gives me 31.36 for this, and 8.93 squared becomes 79.7449. And then our next step is we add them, which gives us this, and then we square root it, and that gives us 10.54063091. And but this is not a final answer, so we cannot write A equals this because we still have to do significant digits. So let's go back and see how we're going to do the significant digits. So here we are squaring it. Squaring is the same thing as multiplying, so the rule for multiplication, so we'll look at the number of significant digits. So there's two significant digits, so this must have two significant digits. Remember, we look from the left because this is in decimal place, so 1, 2, 2 significant digits. This one had 3 significant digits. We maintain that by picking 3 here, 79.7, 1, 2, 3, 3 significant digits. So our next step is that we are going to add these two numbers. So now the rule for adding comes into play. So for the rule of adding, remember, now we are looking at the guess digits. So this one has a guess digit, the 1 is a guess digit, and here 7 is the guess digit. So remember, we look for the least precise guess digit between the two numbers. This one is in the tenths column. This one is in the units column. So obviously tenths, units. The units column is the least precise. So when we are adding them, we're going to choose the units column as our parameter for guess digit choice. So units column here, 1 is in the units column, so we're going to have 3 significant digits including this last one. So there's 1, 2, 3 significant digits. Remember, this 3 significant digits doesn't come from here. It comes from the fact that 1 is in the units column, so this one here is in the units column, so whatever is before the units column, we choose everything. So that's why it gives us 3 significant digits. And now we are square rooting it. Square rooting is again the same rule as multiplying or dividing. So now we again look at the significant digits, 1, 2, 3 significant digits. So this gives us 3 significant digits. Since there's a decimal point, we count from the left, 1, 2, 3 significant digits. And so the number after the last digit is 4. 4 is below 5, so we don't have to worry about increasing this to 6. So our final answer is 10.5 units. So A here is equal to 10.5 units. And that's how we solve combined problems.